I'll deal with this one. Something that we got nowadays.
Oh, okay. Forgot how to use it.
The next time you want hookers, we'll go for, this is the first time I went with them. I mean,
Well, thank you for coming tonight. In an article on lifescience.com called What Are X-rays? It stated that in 1895, a German professor named William Röntgen was working in his lab with a high voltage cathode ray tube. And also in the lab nearby, he had some crystals that he noticed were giving off a fluorescent glow. And even when he put a dark piece of paper over the crystals, they still continued to glow. So he concluded that there must be some mysterious form of energy coming from the cathode ray tube that was able to penetrate the paper and illuminate the crystals. And he called this mysterious energy X-radiation. So in this speech, I'm going to inform you about 3 specific characteristics of X-rays. Characteristic 1 is that they're an electromagnetic wave, and they're part of the electromagnetic spectrum that they share with other electromagnetic waves. The second characteristic is that they operate at extremely high frequencies and they contain high energy. And the third characteristic of X-rays is that they can be produced in nature by natural processes, but they can also be created by man-made devices. So the first characteristic, that X-rays are an electromagnetic wave and that they lie in the electromagnetic spectrum, which is a wide range of frequencies of electromagnetic waves. At the bottom of the spectrum, you have radio waves, which include FM, AM, UHF, VHF, and above that you have infrared, you have the visible light spectrum, you have the ultraviolet spectrum, and then way at the top of the spectrum you have ultraviolet, X-rays, and gamma rays. Now, electromagnetic waves consist of both a changing electric field and a changing magnetic field. And the frequency of the rate of change determines where in the spectrum the electromagnetic radiation lies. And that brings me to my second characteristic of electromagnetic waves and X-rays, is their energy. Because the higher in frequency an electromagnetic wave operates at, the higher the energy it contains. And at frequencies above or higher than visible light, electromagnetic waves have the potential to cause tissue damage. So in the ultraviolet spectrum of the EM spectrum, ultraviolet waves can actually do damage to your skin, and this is what causes suntans or sunburns. But above the ultraviolet range, you have the X-ray and the gamma radiation range. Now, X-rays are considered extremely dangerous because they can not only penetrate living tissue, but they can cause damage to it. And in the textbook Electromagnetics Explained, it goes into detail about how electromagnetic radiation can damage tissue. And it's for this reason that things such as medical X-rays, computed tomography scans, all have to be strictly limited due to the potential harm that they can do to the human body. So the third characteristic of X-ray radiation is that it can be produced both naturally and it can be produced by man-made devices. So you've heard of radioactive isotopes of elements like uranium-238 or tritium, which is heavy hydrogen. These radioactive elements, due to the radioactive decay, can give off X-ray radiation. Now, if you want to generate an artificial X-ray, you have to use a man-made device. And in the basics of X-ray physics, and online article. It's explained in great detail how you go about creating an X-ray with a man-made device, but basically you need three elements in order to create an X-ray. The first thing you need is a source of electrons, which are a negatively charged particle. The second thing you need is a means of accelerating these electrons to extremely high speeds. And in order to accelerate an electron to a high speed, you usually accelerate through an electric field, a very high one. And then once you've accelerated the electrons, you need a metallic target for the electrons to strike. Because when the electron strikes the metallic target and interacts with the atoms of the metallic target and knocks electrons free from those elements, or from those atoms, and in doing so, you create an X-ray. It's really an exchange of energy between the kinetic energy of the accelerated electron and it imparting that on the atom within the metallic target to transform that energy from kinetic energy into radioactive or electromagnetic energy. So those are the three most important characteristics of X-rays. Now, the first is that they're an electromagnetic wave, which a lot of people don't realize, is that they're related to things like radio waves, they're related to microwaves, ultraviolet radiation, visible light, and then of course the third is that they're produced in nature. They're not something that's strictly man-made, but if you want to produce them for things like medical imaging and materials scanning, you can create them and direct them at certain targets. So I think we'll all agree that there's no doubt that Professor Röntgen's important discovery over 120 years ago has done quite a bit to advance the science of medical imaging as well as material imaging. Thank you for your time.
So that's why they put that metal plate behind your back when they do your chest x-ray.
Yeah.
Because it's got to bounce off it.